Light is more than brightness. It is the measure of reality itself. Across the silent vacuum, it races at a speed that defines the rhythm of the cosmos. Neither slower nor faster, but absolute. For all the vastness of the universe, for all the power of black holes, for all the strangeness of quantum fields, there exists one haunting truth. Nothing can outrun a beam of light. Not a particle, not a signal, not even time itself. This law, revealed by Einstein in 1905, is not a matter of engineering or technology. It is not a barrier that cleverness might break. It is a limit written into the fabric of space-time. For to move faster than light would not merely be to move quickly. It would be to unravel cause and effect, to collapse the order of time, to destroy the coherence of the universe itself. And yet, this limit is as mysterious as it is fundamental. Why should the cosmos set such a speed? Why not faster? Why not infinite? The answers lie in relativity, in geometry, in the strange truth that energy and mass curve space-time itself. They lie in the way photons, massless, eternal, carve out the very shape of possibility. To understand why nothing can go faster than the speed of light is to glimpse the skeleton of reality. It is to see not only the laws of physics, but the boundary that makes existence possible. Tonight, we follow that light, not as passengers, but as seekers, into the heart of relativity, into the limits of speed, into the haunting beauty of the fastest thing the universe allows. Einstein's revolution. At the turn of the 20th century, the world believed it understood motion, space, and time. Physics was a grand cathedral, built stone by stone through the laws of Newton. For more than 200 years, those laws had explained planets and pendulums, tides and trajectories, machines and measurements. They painted a universe governed by absolutes, a single time flowing everywhere, a single space stretching uniformly in every direction. The cosmos, it seemed, was a stage upon which events unfolded with perfect clarity. But cracks had begun to form in the cathedral. Experiments with electricity and magnetism hinted at mysteries Newton's laws could not explain. Light, that elusive and dazzling phenomenon, behaved as if it were both wave and particle, both substance and nothingness. And in 1887, the famous Michelson-Morley experiment shocked the scientific world. Designed to detect the motion of Earth through a hypothetical medium called the ether, the invisible substance thought to carry light waves, it found nothing. The Earth moved, yet light showed no difference in speed. No matter how the experiment was arranged, light traveled at the same pace. This result defied reason, and yet it was undeniable. Into this confusion stepped Albert Einstein, a 26-year-old patent clerk working in Bern, Switzerland. In 1905, in what is now called his miracle year, he proposed a radical idea: the speed of light is constant. It does not matter how fast one moves, how quickly one chases or flees. Light will always appear to travel at exactly the same speed, 300,000 kilometers per second, an unchanging pulse in the heart of the universe. From this simple postulate, the edifice of reality shifted. If light's speed is constant, then time and space themselves cannot be. They must bend and stretch to preserve the law. Moving clocks, Einstein revealed, would tick more slowly. Moving rulers would shrink. The faster one traveled, the more reality itself would warp to keep the speed of light fixed. This was a revolution, not only of physics, but of perception. Time, once thought absolute, was revealed as relative, flowing differently for each observer, depending on their motion. Space, once imagined as a fixed container, became pliant, changing with velocity. The universe was not the cathedral Newton envisioned, but something stranger, more fluid, more alive. Einstein's theory of special relativity was not just an intellectual shock, it was a philosophical earthquake. It implied that simultaneity, the idea that two events happen at the same time, is not universal. What is simultaneous for one observer may not be for another if they are moving differently. Time itself became local, subjective, dependent on perspective. The present was no longer absolute, and yet out of this upheaval came order. The constancy of light bound together space and time into a single fabric, spacetime. Hermann Minkowski, Einstein's former teacher, gave this vision its mathematical form in 1908. He declared that space and time are no longer separate entities, but fused into a four-dimensional continuum, curved and structured by the speed of light. The universe was not chaos, but geometry. And at its core, light defined what was possible. Consider what this means. If you chase after a beam of light at nearly its speed, you might expect to see it slow down, but you will not. The beam will still race away from you at the same 300,000 kilometers per second. To preserve this law, the universe plays its strange tricks. Your time dilates, slowing relative to the rest of the world. Your lengths contract, shrinking in the direction of travel. Your mass increases, demanding more energy for every increment of speed. The cosmos reshapes itself to guard the constancy of light. No other speed enjoys this protection. For any ordinary motion, a car, a plane, even a rocket, velocities add and subtract normally. But with light, the rules break. Its constancy is inviolate, an absolute woven into the fabric of reality. The speed of light is not merely fast, it is the ultimate speed, the limit of causality, the heartbeat of the universe itself. This was not easy to accept. Many resisted, clinging to the comfort of Newtonian absolutes. Yet experiments confirmed Einstein's vision again and again. Time dilation, once a theoretical prediction, was measured in the decay of subatomic particles traveling near light speed. Length contraction revealed itself in particle accelerators, where protons racing close to c shrink in the direction of motion. Even GPS satellites today must correct for relativistic effects, their clocks ticking differently from those on Earth's surface. Without Einstein, our navigation systems would falter, our technology would drift into error. Relativity was no abstract dream. It was reality, tested and proven, reshaping both science and daily life. But perhaps the most haunting consequence of Einstein's revolution was not practical, but philosophical. If time and space are relative, then the universe we inhabit is not uniform, not the same for all. Each observer moves through their own slice of space-time, each with their own rhythm of clocks and rulers. Reality becomes a patchwork of perspectives, stitched together by the speed of light. The present dissolves into a relativity of nows. And yet, through this relativity, light remains constant. It is the thread weaving all perspectives into coherence, the universal messenger across the cosmos. Without it, causality would fracture, order would collapse. Light is not only what we see, it is what makes seeing and reality possible. Einstein's revolution did more than dethrone Newton. It revealed a universe governed by limits. For no matter how much energy one pours into motion, no matter how powerful the rocket or how advanced the engine, nothing with mass can reach the speed of light. The closer one approaches, the more energy is required. At light speed, the demand becomes infinite. The barrier is not technological, it is ontological. It is written into the nature of reality itself. To live in this universe is to live with this limit. And while it frustrates the imagination, while it forbids dreams of instant travel to distant stars, it also provides stability. For without the speed of light as a boundary, causality itself would unravel. Faster than light travel would mean messages sent into the past, paradoxes where effect precedes cause, contradictions that would make reality incoherent. The barrier is not cruelty, it is protection. This was Einstein's revolution, the recognition that the universe is not a playground without rules, but a fabric structured by light. Space and time bend to guard its constancy. Causality flows along its pathways. Reality itself depends upon its limit. And yet, for all its finality, this truth does not diminish wonder. For to know that nothing outruns light is also to know that light defines the possible. It carries every image of stars across billions of years. It preserves the story of the cosmos in waves traveling endlessly through the dark. Every photon reaching your eyes tonight began its journey long ago, traveling at the one speed allowed, the one rhythm that never breaks. Einstein's insight was not just scientific, it was poetic. He showed that the fastest thing in the universe is not an object among others, but the very foundation of reality. Light is not simply fast, it is the measure of all speed, the sculptor of time, the guardian of causality. In 1905, a young patent clerk looked at the contradictions of physics and saw through them. He glimpsed a deeper order, one that rewrote everything we thought we knew. From that moment onward, the universe would never again appear the same. Time and space were no longer absolutes. They were shadows of a deeper truth, bound together by light. And in that truth lies one of the most haunting facts in all of science. Nothing, anywhere, can go faster than light. Time, dilation, and length contraction. The first consequence of Einstein's revelation was as unsettling as it was undeniable. If the speed of light is constant, then time itself cannot be. For centuries, humanity believed that time was universal, flowing like a single river through all of existence. Each clock, each heartbeat, each star was thought to keep pace with the same steady beat. But relativity shattered that illusion. Time, Einstein revealed, is not a shared rhythm. It is personal, relative, dependent on motion. Imagine two clocks, once synchronized, placed in different states of motion. One remains on Earth, ticking in the quiet rhythm of home. The other is placed on a spacecraft, launched into the darkness, accelerating toward the speed of light. From the perspective of those on Earth, the traveling clock begins to tick more slowly. Its seconds stretch, its minutes lengthen, its hours drift behind. When the traveler returns, less time will have passed for them than for those who remained behind. This is not illusion. It is not trickery of perception. It is time itself bending under the weight of speed. This phenomenon is called time dilation, and it has been measured not in imagination, but in experiment. Subatomic particles called muons are born in the upper atmosphere, created when cosmic rays collide with atoms high above Earth. These particles decay quickly, living for only microseconds before vanishing. By classical physics, they should never reach Earth's surface. Their lifespans are too short. Yet they do arrive, detected in laboratories, because as they race near the speed of light, their internal clocks slow. Time dilates for them, stretching their brief lives into journeys long enough to descend into our detectors. Without relativity, the presence of muons at Earth's surface would be a paradox. With relativity, they are inevitable. The same effect occurs in machines built by human hands. Particle accelerators hurl protons and electrons close to light speed, and their lifetimes extend beyond what rest would allow. Engineers must correct for relativistic effects because the universe demands it. Even in the skies above, GPS satellites orbit Earth with clocks that tick differently from those on the ground. If not for relativistic corrections, both from their speed and from the warping of time by Earth's gravity, our navigation systems would falter, leading us astray by kilometers each day. Technology itself testifies to the bending of time, yet the strangeness of relativity does not end there. Alongside time dilation comes another distortion, length contraction. From the perspective of the Earth, the spacecraft racing near light speed is not only slowed in time, but shortened in space. Its length in the direction of motion compresses, as though reality itself were squeezing it flat. The faster the ship travels, the more severe the contraction, until at the speed of light, the distance shrinks to nothing. This contraction is not illusion. It is the geometry of spacetime adjusting itself to preserve the constancy of light. Just as time stretches for the moving traveler, space shrinks in the direction of motion. Both bend together, weaving into a consistent whole. For the traveler, the story is different. On board the spacecraft, the clock ticks normally, seconds passing in their familiar rhythm. The ship feels unchanged, solid, and steady. It is the outside world that shifts. Distances shorten, stars draw closer. Journeys that would take millennia at rest become reachable within a single lifetime. Time dilation and length contraction are two sides of the same coin, the balance that preserves the speed of light. This symmetry is haunting. From one perspective, the traveler slows. From another, the universe itself compresses. Both are true, both are consistent, both arise from the relativity of time and space. There is no single story. Reality itself depends on where one stands, how one moves, what path one takes through space-time. Consider what this means for the dream of interstellar travel. A journey to a star dozens of light years away seems impossible within a human life. Yet relativity whispers of a loophole. For the traveler moving near light speed, time slows. Decades may pass on Earth, centuries may slip by for those left behind, but for the traveler, only years may flow. Distance contracts, clocks slow, and the unreachable becomes reachable, though always at a cost. The traveler returns to a changed world, their own time unmoored from those they left. This paradox is captured in the famous thought experiment known as the twin paradox. One twin remains on Earth, while the other journeys near the speed of light. When the traveling twin returns, they are younger, their clock having ticked fewer times. This is not imagination, but consequence, measured and confirmed in laboratories, etched into the equations of relativity. Time dilation and length contraction reveal a universe where experience is not absolute, but relational. Each observer inhabits their own fabric of time, their own scale of distance, their own rhythm of reality. The cosmos is not one melody, but a polyphony, harmonized only by the constancy of light. And yet, for all its strangeness, there is order. No matter how time bends, no matter how space contracts, the structure of causality remains intact. Events follow one another, bound by the speed of light. Nothing can outpace it, and so no paradox of cause and effect arises. Relativity bends reality, but it does not break it. Perhaps the most haunting aspect of this truth is how it reframes the human experience of time. We often think of the present as universal, shared by all who exist. but relativity dissolves this. The present for one observer is not the present for another if their motions differ. There is no single now, only a vast web of relative times, each anchored to its own perspective. This realization is unsettling, but also profoundly beautiful. It suggests that the universe is richer than our intuitions allow, a tapestry of moments interwoven across motion and perspective. Time is not a river flowing evenly for all. It is a network of streams, branching, converging, diverging, always bounded by light. And yet, even as relativity shatters absolutes, it offers a kind of peace. For though time and space are malleable, they are malleable in harmony. Every dilation, every contraction, every shift conspires to preserve the speed of light. It is the constant at the heart of change, the anchor in a sea of relativity. When Einstein first proposed this vision, it must have seemed alien, even absurd, but experiment after experiment confirmed it. Today we navigate with satellites because clocks tick differently in orbit. We measure particles living longer than nature seemed to allow. We know that time is not universal, that space is not rigid, that reality itself bends under the weight of speed. The implications are profound. If time can slow and space can shrink, then our most basic intuitions about duration, about distance, about reality itself, are but approximations. The universe is not built to match human expectation. It is stranger, deeper, more flexible. And in that strangeness lies its haunting beauty. To grasp time dilation and length contraction is to glimpse the malleability of existence. It is to see that speed is not just motion, but transformation. It is to realize that the universe, at its most fundamental level, bends itself to preserve the law of light. And in this bending, we discover the truth. Time and space are not absolutes, but partners in a cosmic dance. They stretch, they shrink, they yield, all to guard the constancy of light. Nothing can go faster, for faster would undo the order of things. Faster would break the fabric. Faster would erase cause and effect. The speed of light is not merely a number. It is the foundation of reality, the geometry of spacetime. When Einstein showed that time and space were not absolutes, but pliant, bending to preserve the constancy of light, a deeper vision soon followed. The universe, it turned out, was not built on two separate foundations, one for time and one for space. They were not distinct arenas, stitched together only by our senses. Instead, they were one, a seamless fabric stretching in 4 dimensions, weaving every moment and every place into a single whole. It was Hermann Minkowski, Einstein's former mathematics teacher, who gave this vision its enduring form. In 1908, he declared that henceforth space by itself and time by itself were destined to fade into shadows. Only a union of the two would preserve meaning. The word he gave this union was spacetime. This idea was radical. For centuries, philosophers had imagined space as a container, an infinite box within which matter resided. Time was imagined as a universal clock, a steady tick marking the passage of all events. But relativity showed these intuitions to be illusions. Space has no existence apart from time. Time has no existence apart from space. Together, they form a single continuum, and its structure is not simple, but geometric. Mass, energy, and the cost of speed. The dream of speed has always haunted humanity. From the first runners tracing across the earth to the machines that now carry us into the sky, we have sought to move faster, to close distances, to conquer time. But the cosmos places a limit, and in Einstein's equations, that limit is not only a rule, but a warning. The closer one comes to the speed of light, the more the cost rises until it becomes infinite. At the heart of this truth lies the most famous equation in science: E equals mc squared. Energy equals mass times the square of the speed of light. With these few symbols, Einstein revealed that mass itself is a form of energy, and energy is bound to mass. The universe is not built of separate categories, but of transformations. To accelerate an object is not only to change its motion, but to pour energy into its very essence. At ordinary speeds, the cost is modest. A car doubles its velocity, and the energy demand grows as expected. But as speed climbs, as one approaches a significant fraction of light's relentless pace, the relationship bends. Energy no longer adds linearly. It begins to rise steeply, then more steeply still. For each increment of acceleration, more and more energy is required. At 90% of light speed, the demand is immense. At 99%, it becomes colossal. At the final threshold, the speed of light itself, the cost becomes infinite. No amount of fuel, no engine however vast, no power drawn from the stars themselves could supply what is needed. This is not a failure of technology. It is a law of being. Mass resists acceleration in proportion to its energy, and as velocity increases, so does resistance. The object seems to grow heavier, its inertia rising without bound. It does not literally gain mass in the sense of substance, but its energy grows, and with it, its resistance to change. To push further is to fight the universe itself, and the universe will not yield. This is why photons, the quanta of light, move at light speed effortlessly. They carry no rest mass, only energy. For them, the demand is not infinite, for there is no mass to drag. They were born at the speed of light, they live at the speed of light, and they will never know any other pace. But anything with mass, however small, is bound to the struggle. It may approach but never reach, and certainly never exceed. The haunting beauty of this truth lies in its symmetry. The same law that forbids faster than light travel also explains the energy bound within matter itself. The fire of the sun, the devastation of nuclear reactions, the warmth in every atom's binding, all are consequences of E equals mc squared. Mass and energy are the same, and their interchange gives both power and limit. To ask for infinite speed is to ask for infinite energy, and infinity is not available to the finite. This law reshapes how we imagine journeys among the stars. A spacecraft, however advanced, cannot simply accelerate endlessly. Each step closer to light speed demands exponentially more energy. The rocket equation compounds the problem. The fuel required to accelerate must itself be accelerated, requiring more fuel still. Soon the logic collapses under its own weight. Even with antimatter, even with fusion, even with the most efficient engines we can dream, the limit holds. The speed of light is not only distant, it is unreachable, and yet the cost of speed is not only mechanical, it is temporal. As an object accelerates, time for it slows. Lengths contract. The universe conspires to ensure that the barrier is never breached. In one sense, this offers hope. Even as the traveler never reaches light speed, they experience time differently, allowing them to cross vast distances within their own frame of reference. In another sense, it is a reminder of constraint. For those left behind, centuries will pass. Energy and time entwine in a paradox of longing. The deeper one contemplates this law, the more it feels like poetry. The cosmos grants us the ability to move, but ties motion to cost. The closer we come to the ultimate speed, the more reality resists, as if guarding its own coherence. If faster-than-light travel were possible, cause and effect would collapse, paradoxes would bloom, and the universe would unravel. The barrier is not cruelty. It is the architecture of order. Still, imagination lingers. We dream of warp drives, of shortcuts through wormholes, of particles that somehow slip past the limit. But every such dream encounters the same wall: energy. The Alcubierre warp drive, a theoretical bubble of space-time itself, requires exotic matter with negative energy densities, something never observed. Wormholes, if they exist, demand stabilization by energy forms that defy known physics. Tachyons, hypothetical faster-than-light particles, remain forever in the realm of speculation, incompatible with causality as we know it. Again and again, energy demands rise beyond reach, until the dream collapses back into the silence of theory. And yet, there is comfort here. For the limit, while frustrating, is also a gift. It ensures that the universe is intelligible, that signals cannot leap into the past, that history has order. Without the cost of speed, reality itself would be incoherent. The boundary is the condition of stability. Light speed is the scaffolding upon which causality rests. In the quiet of reflection, one sees the symmetry. The same equation that powers stars and binds nuclei also defines the boundary of motion. Energy is not endless. Mass is not free. The cosmos demands balance, and in that balance lies both beauty and restraint. The dream of speed is eternal, but the reality is deeper. To race faster than light would be to tear the fabric of space-time, to drain infinity itself. The cost cannot be paid, and so we remain bound, explorers not of infinite speed, but of finite journeys, weaving meaning into the spaces between stars at the pace allowed. Perhaps that is enough, for in the struggle against limit lies humanity's story, reaching, striving, imagining, even when the law cannot be broken. The cost of speed reminds us not of failure, but of boundary. And in boundary, existence finds coherence. Nothing outruns light because to do so would demand infinity. And infinity, though glimpsed in equations, never yields itself to the finite. Imagine the life of a single particle. At each instant, it occupies a point in space and a moment in time. Connect these points and a line emerges, a world line, tracing its path through space-time. Every being, every star, every photon has such a world line, a thread in the grand tapestry. Space-time is not merely backdrop. It is the stage and the script, the loom and the pattern, the very fabric upon which existence is embroidered. In this fabric, light defines possibility. Every event in space-time radiates outward at the speed of light, forming a cone, the light cone, that divides reality into past, present, and future. Inside the cone lies causality, the realm of what can be influenced and what can influence. Outside lies elsewhere, regions forever disconnected, unreachable by any signal. To move faster than light would be to leap outside the cone, to step into paradox, to violate the order that makes reality coherent. This geometry is not abstract. It is the architecture of cause and effect. If you stand in a room and switch on a lamp, the light ripples outward, expanding in a sphere. Everything within reach of that light lies inside the cone of your action. Nothing outside can yet be touched, for no message travels faster. Space-time is structured by this limit, carved into regions of influence and separation. The speed of light is the slope of the cone, the defining angle of possibility. From this vision emerges a haunting truth. The universe is not a universal now. There is no single present that binds all beings together. Each observer slices space-time differently, depending on their motion. What is present for one may be past or future for another. The geometry of space-time ensures consistency, but not simultaneity. The world is a patchwork of perspectives, each one valid, each one partial. The dream of a single shared moment dissolves into relativity. Yet in this dissolution arises something profound. For while time bends and space warps, while present becomes relative and distance shrinks, causality remains intact. No event outside the light cone can influence you. No message can leap backward in time. The geometry preserves order. Even as it denies absolutes, it offers consistency. To visualize this, physicists often speak of space-time diagrams. Imagine a graph with time rising vertically and space stretching horizontally. A stationary observer traces a straight vertical line, while a moving one tilts diagonally. Light alone moves at 45 degrees, the perfect slope of the cone. Nothing can exceed that slope. Nothing can step outside its angle without tearing the fabric itself. In this simple diagram lies the entire logic of relativity. It shows why faster-than-light travel leads to paradox, why signals into the past become possible, why causality collapses. The geometry forbids it not as arbitrary law, but as necessity. The speed of light is the line that binds order. Einstein's revolution thus became not only about motion, but about geometry. Physics transformed into the study of the fabric itself. In the years that followed, Einstein would extend relativity into its general form, showing how mass and energy warp space-time, curving the paths of planets, bending the flow of time itself. But even before that deeper insight, the special theory already revealed the haunting beauty of the structure. Space and time are not separate realities. They are the geometry of being. This vision reframes what it means to exist. To live is to trace a world line, a path through the continuum. To interact is to weave cones of influence, intersecting with others, joining in causal dance. Each choice, each action, ripples outward at light speed, shaping the future inside the cone, leaving the elsewhere untouched. Existence itself becomes geometry, and geometry becomes fate. And yet, for all its abstraction, this truth is strangely calming. The universe, though vast and incomprehensible, has order. There are rules written into its fabric, boundaries that ensure coherence. The speed of light is not merely velocity, it is the scaffolding of reality, the slope of causality, the angle that holds existence together. It also reframes our place in the cosmos. We are not merely beings moving through time, carried helplessly forward by its flow. We are patterns in space-time, woven into the continuum. Our past is etched into the fabric. Our futures extend into cones of possibility. Our present is the moment where world lines cross. Death does not erase the path. The world line remains, a thread in the tapestry. Minkowski's insight, joined to Einstein's, gave physics not only a new mathematics, but a new metaphysics. To be is to be extended in space-time, not only here but there, not only now but across the whole trajectory of life. The self is not a moment, it is a curve, and light is the measure of its slope. When one contemplates this geometry, the strangeness of relativity softens into elegance. Time dilation, length contraction, the relativity of simultaneity, all emerge not as contradictions, but as geometry made visible. The universe bends because it must. The fabric flexes to preserve coherence. There is no chaos, only the hidden order of the cone. And so, the haunting speed of light is no longer merely a number, 300,000 kilometers per second. It is the constant that defines geometry, the foundation of causality, the heartbeat of the cosmos. It is why nothing can go faster, why every path bends within the cone, why the universe has order instead of paradox. In the end, geometry does not diminish wonder, it deepens it. To see spacetime as fabric is to glimpse the skeleton of reality, the hidden architecture of existence. And within that structure, light defines the possible. Faster than light is not forbidden by decree. It is forbidden by shape. It is excluded by geometry. It is erased by the way the fabric itself is woven. Nothing outruns light because light is not a thing within spacetime. It is the measure of spacetime itself. It is the slope of the cone, the guardian of causality, the architect of possibility. To ask what lies beyond is to ask what lies outside the fabric of reality. And the answer is silence, photons, the light beings. Light is not only a limit, not only the barrier that defines motion. It is itself a presence, a being that moves always at the very edge of possibility. To understand why nothing can go faster than light, we must understand what light itself is. Not just illumination, but the very heartbeat of spacetime. A photon, the quantum of light, is unlike anything else we know. It has no rest mass, no weight in stillness, because it is never still. It is born at the speed of light. It exists at the speed of light, and it dies at the speed of light. For a photon, there is no alternative. To ask what happens if it slows is to ask what happens to a shadow when the sun goes out. It is not reduced, it is erased. This nature gives photons a strange and haunting property. They experience no time. For us, time stretches forward in hours and days, measured by the tick of clocks and the rhythm of breath. For a photon, there is no rhythm. From its perspective, the moment of its birth and the moment of its absorption are one and the same. A photon emitted in the heart of a star and absorbed billions of years later in the lens of a telescope has, in its own frame, taken no journey at all. It has crossed space without duration. This timelessness reframes how we see the cosmos. The starlight that reaches us tonight, born in the fusion furnaces of suns that may have died long ago, carries with it not only energy, but immediacy. For the photon, there was no waiting, no travel, no journey across ages. It was always here, always in the act of arrival. We see the past, yet the photon knows no past. We gaze into time, yet the photon exists only in the eternal present. Photons are also indivisible. They are quanta, the smallest packets of electromagnetic energy, unable to be split into halves. They can be absorbed or emitted, but never divided. Each one is a unit of existence, discrete and whole, carrying a frequency that encodes its energy. Red light, blue light, X-ray, or radio, all are photons, distinguished only by energy and wavelength. Their identities are simple, yet their behavior is anything but. For light behaves as both wave and particle, a paradox at the heart of quantum theory. In experiments, photons create interference patterns, spreading like ripples, interfering with themselves as if they were waves. Yet when measured, they strike as particles, single points of energy, indivisible and precise. They are both and neither, wave and particle, depending on how we ask the question. Reality itself seems to shift its answer to meet our gaze. And yet, whether wave or particle, photons obey the same law. They move at light speed, always. They define the boundary between the possible and the impossible. Their constancy is not only physical law, it is the structure of space-time itself. They are the threads by which the fabric is woven, the lines along which causality flows. Without them, no signal could pass, no information could move, no universe could exist as we know it. Photons are also messengers. Every image we have of the cosmos, the stars, the galaxies, the afterglow of the Big Bang itself, is carried to us by light. Photons stream from the edge of the observable universe, telling us stories from billions of years ago. They are time travelers of a kind, revealing to us what was, even if they themselves never experienced the interval. The universe we see is the universe of light, sculpted by photons that bring us the past in every glimmer. And yet, light is not limited to what we can see. The human eye perceives only a narrow band of wavelengths, a thin slice of the spectrum. Beyond lie radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays, all photons, all carriers of energy, all moving at the same speed. Telescopes tuned to these bands reveal a cosmos invisible to sight, filled with structures we could never otherwise know. Light, in its many forms, unveils the hidden universe. The strangeness deepens when we look closer. Quantum experiments reveal that photons can become entangled, their states linked across distance in ways that defy classical thought. Change one, and the other responds instantly, no matter the separation. This entanglement does not allow faster-than-light communication, for the universe guards causality with iron law. But it reveals that photons are not merely particles flitting through space. They are part of a deeper whole, connected in ways we do not yet fully understand. In this, photons hint at mysteries yet unsolved. They suggest that the fabric of spacetime is not the final stage, but a surface upon deeper laws. Quantum fields, entanglement, the strange union of relativity and quantum mechanics, all converge upon light. The photon sits at the intersection of the greatest puzzles in physics, simple in form yet unfathomable in nature. And still, for all its strangeness, the photon remains our guide. Its constancy is the foundation of relativity. Its speed defines the cone of causality. Its presence makes sight possible, knowledge possible, existence itself comprehensible. To understand why nothing can go faster than light is to understand that light is not just another particle, but the very structure of possibility. Reflect then on what this means. Each photon you see, each glimmer that strikes your eye, is a messenger from elsewhere, timeless in its journey, indivisible in its being, constant in its speed. It does not know waiting. It does not know slowness. It is born. It moves. It ends, all in one eternal instant. For us, it is the past arriving in the present. For the photon, it is always now. Perhaps this is the most haunting truth of all, that the universe itself is lit by beings of timeless speed, carrying across emptiness the story of stars, galaxies, and worlds. Without them, there would be only silence and darkness. With them, there is knowledge, connection, coherence. Nothing can outrun light because light itself is not bound by the categories of mass and motion. It is the measure of them. It is the definition of the possible. To be a photon is to exist at the edge of reality, timeless, massless, eternal in speed. And through their presence, the universe reveals itself to us again and again in every moment of sight. Dreams of breaking the limit. From the moment Einstein revealed that nothing with mass could reach the speed of light, the human imagination rebelled. To accept a barrier is to accept limitation, and limitation has never sat easily with our species. We dream of surpassing, of breaking boundaries, of touching the impossible. And so, even as science declared the speed of light the ultimate law, stories and theories arose, searching for cracks in the wall, for secret passages through the cosmic prohibition. The first of these dreams was the notion of particles that already lived beyond the boundary. Physicists named them tachyons, hypothetical beings that could only exist faster than light. Unlike ordinary matter, they would never slow below the barrier. For them, to move at subliminal speeds would require infinite energy, just as for us to move above requires the same. They would always remain on the other side, unreachable, forever alien. But tachyons, if they exist, carry troubling implications. Their very nature would permit violations of causality, messages sent into the past, paradoxes blooming like cracks in the mirror of reality. The equations allow their possibility, but nature seems silent, as if the universe itself refuses to harbor them. Another dream arose not from particles, but from space itself. If nothing can move faster through space-time, perhaps space-time could move faster around us. This is the idea of the warp drive, made famous by fiction, but born in mathematics. In 1994, physicist Miguel Alcubierre described a solution to Einstein's equations in which a bubble of space-time contracts in front of a ship and expands behind it. The ship within does not move faster than light, relative to its bubble, yet the bubble itself rides the expansion of space, carrying it across distances at apparent superluminal speed. The mathematics is elegant, but the requirements are extraordinary. To bend space-time in this way demands exotic matter with negative energy density, a substance never observed, a kind of anti-energy that defies known physics. Without it, the warp drive remains dream, a shimmering vision unmoored from reality. Wormholes present another tantalizing vision. Einstein himself, with his collaborator Nathan Rosen, described them in 1935. Bridges through space-time, tunnels connecting distant regions, shortcuts across the immensity of the cosmos. A ship passing through a wormhole might emerge light years away in moments, not by breaking the speed limit, but by bypassing distance itself. Wormholes, too, demand exotic matter to remain stable. Without it, they collapse instantly, closing faster than any traveler could pass. And like warp drives, they tempt paradox. A wormhole manipulated into a time machine would unravel causality, forcing the same contradictions that relativity so carefully guards against. Even quantum mechanics has offered its illusions. Entanglement, the eerie connection between particles, suggests instant communication across distance. Change one, and the other responds, no matter how far apart. To the human imagination, this seems to defy the speed of light. But the universe holds firm. Entanglement cannot transmit usable information faster than light. The correlations appear only when compared afterward, when classical signals have caught up. The cosmos permits strangeness, but not violation. The barrier remains intact. And yet, despite the physics, the longing persists. For interstellar distances are vast beyond comprehension. The nearest star lies more than 4 light-years away. Even at the fastest speeds humanity has ever achieved, it would take tens of thousands of years to reach it. The Milky Way stretches 100,000 light-years across. To cross it with present technology would require epochs longer than civilizations endure. Beyond it lie billions of other galaxies, scattered like jewels across the black, each forever distant at human scales. The speed of light, in its constancy, imprisons us within a tiny neighborhood of the cosmos. It preserves order, but at the cost of cosmic isolation. Perhaps it is this isolation that fuels the dreams. To imagine tachyons, warp drives, wormholes, or entanglement as escape routes is to refuse the loneliness of the stars. It is to insist that we might not be forever bound, that one day we may cross gulfs now unimaginable. Even if the physics resists, the imagination does not. Yet there is another way to see this limit. Perhaps the barrier is not a prison, but a safeguard. Faster-than-light travel would invite paradox, permitting signals into the past, unraveling cause and effect. The universe would become incoherent, contradictions blooming until meaning itself dissolved. The constancy of light is the law that preserves consistency, the reason history flows forward and not backward. To demand its violation is to demand the end of sense. Still, the dreams are not wasted. For in searching the boundaries of what is possible, science deepens its understanding. Warp drives, wormholes, and entanglement may never deliver faster-than-light travel, but they reveal the strangeness of spacetime, the richness of quantum theory, the creativity of human thought. They remind us that physics is not only law, but exploration. To test the impossible is to refine the possible. And perhaps there are truths yet unknown. The history of science is filled with limits once thought absolute, later reframed by deeper understanding. Newton's absolutes gave way to relativity. Relativity itself awaits union with quantum mechanics. Perhaps in some future, new frameworks will show us possibilities we cannot now imagine. Pathways that honor causality yet transcend our current visions. For now, the barrier holds. Light remains the fastest thing in existence, the ultimate messenger of the cosmos. Every dream of surpassing it collapses under the weight of paradox or energy demand. And yet, the longing remains, a testament to human restlessness. We are creatures who look at stars and ache for them, who dream of reaching what cannot yet be reached. The dreams of breaking the limit may never be realized, but they serve a deeper purpose. They remind us that curiosity is not bound by law, that imagination travels faster than any particle. Even if ships never exceed light speed, thought already has, soaring beyond the horizon, painting visions of futures that may never come, but which still inspire. In the end, perhaps this is the gift of the barrier. It humbles us, grounding our ambitions, while at the same time igniting our creativity. It reminds us of our limits, even as it urges us to seek their edges. The speed of light cannot be broken, but in longing for it, humanity finds direction, purpose, wonder. The cosmos does not yield its laws to our will, yet in confronting those laws, we discover not despair, but beauty. The barrier of light is not a cage. It is a frame shaping the picture of reality, giving form to existence. And within that form, imagination still soars. Nothing moves faster than light, yet our dreams will always try. Black holes and horizons. Among all the structures the universe creates, none embody the limit of light more hauntingly than black holes. They are not merely objects, not merely collapsed stars or regions of density. They are boundaries in space-time itself, horizons beyond which light cannot escape. They are the places where the cosmic speed limit ceases to be a law of motion and becomes the very definition of a border. A black hole begins simply in the death of a massive star. Gravity pulls inward relentlessly, crushing the star's core after nuclear fuel is exhausted. If the mass is great enough, no force can halt the collapse. The core contracts, the density rises, and eventually a point is reached where space-time itself folds in on itself. Around this point forms the event horizon, a spherical boundary marking the region where escape becomes impossible. To cross this horizon is to pass from a realm where light can still struggle outward to one where no path exists but inward. The horizon is not a surface of matter. It is geometry, pure and absolute. The horizon is defined by light speed. At that boundary, even light directed outward is pulled back. Photons that might have raced away from any other star are bent and captured. The fastest messengers of the universe, the carriers of causality, are caged. And if light cannot escape, then nothing else can, for nothing else can exceed it. The event horizon is the ultimate manifestation of the limit, the place where the barrier of light becomes the edge of reality. Inside, the mathematics grows stranger. Space-time curves infinitely toward a singularity, a point where density is thought to become infinite, where the known laws of physics falter. The singularity is hidden from view, shrouded by the horizon, yet its presence warps the space around it, bending time, distorting motion, shaping the fate of everything nearby. To orbit close to a black hole is to feel time itself slow relative to distant observers. To approach the horizon is to see the universe speed up, while for the universe, your own clock slows toward stillness. From the outside, matter falling into a black hole never seems to cross the horizon. It approaches, slows, and fades, its light stretched to redder and redder wavelengths until it disappears. To distant eyes, the horizon becomes a frozen veil. Yet for the falling object, the crossing is swift. The boundary is passed without ceremony, the journey inward continuing until space-time itself terminates. Black holes thus remind us that light is not simply speed, but structure. They reveal that the speed of light is the slope of space-time itself, the shape of causal possibility. At the horizon, that slope tilts inexorably inward. Light, the great liberator, becomes prisoner. Beyond lies a realm we cannot see, cannot know, a silence enforced not by walls of matter, but by the geometry of the universe. And yet, black holes are not only devourers, they are also creators of insight. By studying them, physicists have tested the extremes of relativity, probed the nature of space-time, and glimpsed the marriage of quantum theory and gravity. The detection of gravitational waves, ripples in space-time from colliding black holes, confirmed predictions made a century earlier, proving that space-time is not static, but dynamic, trembling under cosmic violence. The imaging of a black hole's shadow by the Event Horizon Telescope revealed, for the first time, the silhouette of the unseeable, a dark void outlined by light swirling at the brink. These achievements show that even when horizons conceal, they also reveal. The very act of defining a boundary illuminates the laws that create it. Black holes, in their silence, speak of the deepest truths. They also force us to confront paradox. If nothing can escape, what becomes of information carried by matter that falls within? Quantum theory insists information cannot be destroyed. Relativity insists nothing can leave. This tension gave rise to the information paradox, a puzzle that has occupied physicists for decades. Stephen Hawking's discovery that black holes radiate, slowly evaporating through quantum processes at the horizon, deepened the mystery further. If black holes can vanish, what happens to the information they contained? No final answer has yet been found, but in the struggle, new theories of space-time and quantum gravity continue to emerge. Thus, black holes are more than cosmic abysses. They are laboratories of the impossible, edges of knowledge where the speed of light defines not only a barrier to travel, but a boundary to understanding. They embody the very theme of the universe's restraint. that nothing moves faster than light, that causality bends but does not break, that horizons exist not to mock us but to frame reality. There is also a strange beauty in contemplating what it means for light to fall. We are accustomed to thinking of light as untouchable, the swiftest of all things, the universal messenger. Yet in the presence of gravity, even photons curve, their paths bending around stars, their destinies captured at horizons. This bending is not defeat, it is revelation. It shows that spacetime is not emptiness, but fabric, pliant and dynamic. The horizon of a black hole is the ultimate demonstration that the fabric can fold upon itself. For those who dream of breaking limits, black holes are humbling. They remind us that the speed of light is not only a velocity, but a prison wall. To imagine faster than light travel is to imagine escape from horizons. Yet the horizon is unyielding. It is not a thing we may surpass with better engines or clever tricks. It is the geometry of existence itself. And yet, even in this confinement, there is wonder. For horizons are not unique to black holes. The universe itself has one. Because the cosmos is expanding, distant galaxies recede from us at speeds greater than light. Their light will never reach us, not because they move through space faster than photons, but because space itself stretches. They cross our cosmic horizon, slipping forever beyond observation. Here too, the speed of light defines what can be known, what can be touched, what lies within the circle of causality. From stellar collapse to cosmic expansion, the same truth resounds. Horizons are written into the fabric of spacetime. They are the boundaries drawn by light speed, the edges beyond which causality cannot follow. They remind us that reality has limits, but that those limits are what give it coherence. To stand beneath the night sky and contemplate black holes is to feel both awe and humility. In their silence, they embody both the danger and the necessity of the speed of light. They consume light, they conceal truth, yet they also reveal the deepest structures of the universe. They are mysteries framed by the one constant law, that nothing can go faster than light. Perhaps that is their greatest gift, for in their very existence, they remind us that the cosmos is not chaos, but order, an order bound together by the most haunting of boundaries: cosmic implications. The recognition that nothing can move faster than light is more than a physical law. It is a principle that shapes the entire architecture of the cosmos. Without it, reality would not resemble the universe we know. With it, order is preserved, meaning is secured, and existence takes on a coherence that would otherwise collapse into paradox. The speed of light is not simply a number. It is the silent governor of causality, the thread that holds the story of the universe together. Imagine, for a moment, a universe without such a limit. If signals could leap instantaneously across distance, if motion could exceed light, then cause and effect would unravel. Messages could be sent into the past. Effects could precede their causes. Paradoxes would bloom like fractures in the foundation of being. The arrow of time itself would lose its meaning, and with it, the possibility of coherent history. In such a universe, every event would risk contradiction, every outcome could be undone, and reality would dissolve into incoherence. The very fabric of spacetime, with its ordered cones of possibility, exists only because there is a maximum speed. This limit does not shrink the universe, it defines it. The cosmic web of galaxies, stretching across unimaginable distances, is connected by light's journey. The light from the first stars still streams toward us, carrying with it the history of the early universe. The afterglow of the Big Bang itself, the cosmic microwave background, is a sea of photons that have traveled for nearly 14 billion years to reach us. If faster-than-light travel were possible, these stories would blur. We would not see the past written in light, for photons would not bind history with consistency. The very act of observation depends on the limit. We see the universe as it was because light, and nothing else, carries information forward at a finite, constant speed. The expansion of the universe, too, is framed by this boundary. As space grows, distant galaxies recede, and some retreat beyond our cosmic horizon, their light forever unable to reach us. This horizon is not a surface of matter, but a boundary of knowledge, drawn by the constancy of light. We live within a bubble of the observable, a sphere defined not by where matter ends, but by how far light has traveled since the beginning of time. Beyond it lies more universe, perhaps infinite, but forever hidden. The speed of light thus shapes not only what is possible, but what is knowable. It defines the edge of our vision. Even within this horizon, the limit sculpts the behavior of the smallest particles. Quantum fields, entanglement, and uncertainty all unfold against the backdrop of relativity. No quantum signal, no matter how strange, can violate the boundary. Entangled particles influence each other's states instantly in ways that defy classical understanding. Yet no information can pass faster than light. The cosmos allows mystery, but it does not allow paradox. The law is unbroken. This consistency preserves the possibility of science itself. If faster-than-light influence were possible, experiments could yield contradictions. Observers might disagree not only on perspective, but on truth. The fabric of causality would splinter, leaving no stable laws to discover. The speed of light ensures that reality remains lawful, that events unfold in patterns that can be studied, predicted, and trusted. In a profound sense, the very intelligibility of the universe is a gift of the limit. Yet the implications extend further still. The constancy of light ties together the vast and the small, the cosmic and the quantum, in a way few other laws do. It defines the curvature of spacetime around stars and galaxies. It sets the rhythm of time for satellites in orbit and for muons racing through Earth's atmosphere. It governs the paths of photons streaming from the edges of black holes and the calculations of engineers designing communication networks. It is the universal thread connecting all scales, and it humbles our ambitions. For as much as we long to leap between stars, to voyage across galaxies, the limit insists on patience. Distances remain vast, journeys long, horizons far. The cosmos cannot be conquered in a rush. It must be explored with the patience of centuries, the endurance of civilizations. The speed of light enforces humility, teaching that the universe is not ours to grasp quickly, but ours to approach slowly, with awe. Yet this humility carries beauty. To look at the night sky is to look back in time, to see light that began its journey before humanity existed. Every star is a message, every galaxy a memory, every photon a traveler bound by the same law. Without the speed of light as a limit, we would not see the past written into the present. The universe would not have story. It would be chaos. The limit gives us narrative, binding history into beams of light that cross the ages to tell us what has been. There is also a philosophical implication, subtle yet profound. The barrier reminds us that human desire does not dictate reality. The cosmos is not shaped to our wants, but to its own laws. We may imagine, we may dream, we may long for faster ways, but the universe holds steady. Its coherence depends on its constancy, and in accepting that constancy, we glimpse something deeper, order as the foundation of existence. The law is not enemy, but ally, not prison, but scaffold. It holds us, frames us, gives us the stage upon which life can unfold without collapse. Thus, the cosmic implications of the speed of light are not only physical, but existential. They remind us that boundaries are not only restrictions, but conditions of meaning. Without them, nothing would cohere. With them, reality has structure, story, and sense. To live within the limit is to live within order. To imagine beyond it is to glimpse paradox. And so, when we ask why nothing can go faster than light, the answer is not only energy, not only relativity, not only geometry. The answer is coherence itself. Light speed is the law that allows time to flow forward, that allows causes to precede effects, that allows reality to exist as a knowable whole. The cosmos is not merely constrained by the speed of light, it is defined by it. The law humbles us, yes, but it also comforts. For it tells us that beneath the vastness, beneath the chaos of galaxies and the strangeness of quantum fields, there is consistency, there is order, there is a boundary that will not yield, and in its refusal lies the possibility of meaning. Nothing exceeds light not because the cosmos is cruel, but because the cosmos is coherent. And in that coherence, life finds a stage, science finds a language, and existence finds its frame, human longing. From the moment humanity first looked to the sky, the stars have called to us. They shimmer not only as lights in the darkness, but as invitations, distant destinations scattered across an unreachable ocean. The constancy of the speed of light makes them untouchable, yet our longing is undimmed. We ache to cross the gulfs of space, to step beyond the small world that has sheltered us, to know what lies on other shores of the cosmos. This longing is woven into our history. We are a species of voyagers. From the first migrations across continents to the crossing of oceans, from the building of sails to the launch of rockets, our story has been one of horizons pursued and boundaries surpassed. Always there has been another shore, another frontier, another place beyond the known. But now we confront the final frontier, and the speed of light stands as the ultimate horizon. Even the nearest stars lie far beyond our reach. Proxima Centauri, our closest neighbor, is more than 4 light-years away. The fastest probes humanity has ever built would take tens of thousands of years to arrive. To cross the Milky Way, 100,000 light-years across, is a journey that mocks the scale of lifetimes. To contemplate the broader cosmos, with its billions of galaxies, is to face distances so vast they silence the imagination. Light connects them, but it also separates, for no message can outrun its pace. The limit humbles our ambition, yet deepens our wonder. And still, we send our messengers. The Voyager probes, launched in the late 20th century, continue to drift outward, bearing golden records of human sound and music, whispers to the cosmos carried at sublight speed. They will wander interstellar space for millions of years, long after Earth has changed beyond recognition, still moving too slowly to approach another star within any human reckoning of time. Yet their journey is a testament to our longing. To leave Earth is to declare that the stars matter, even if they remain unreachable. Our telescopes extend the reach of our eyes, if not our bodies. They drink photons that began their journeys long ago, photons that carry the stories of galaxies as they were billions of years in the past. Each observation is a kind of travel through time, though not through distance. We cannot go to them, but their light comes to us, bringing echoes of their ancient presence. And though we cannot touch them, we are touched by them, by the knowledge they grant, by the awe they inspire, by the longing they deepen. The speed of light defines this relationship. It both allows and forbids. Without it, there would be no coherence, no narrative, no science. But because of it, the stars remain distant, the galaxies unreachable. It frames the tension between desire and reality, between human yearning and cosmic law. To live within this tension is to be human, for our nature is to desire what lies beyond our grasp. And yet, relativity offers a strange promise. Though nothing can exceed light, those who approach it find time itself altered. For the traveler moving near light speed, time slows, distances contract. A journey that would take millennia by Earth's clocks may take only years by theirs. In this way, relativity does not abolish longing, but transforms it. The stars may be reached, but at the cost of separation. Those who depart would return to a different Earth, to a world aged far beyond their own years. Longing is answered, but never without loss. This paradox reveals something essential. The barrier of light is not absolute despair, but it is never free. Every dream of reaching the stars is balanced by sacrifice. The traveler who leaves may never return to the world they knew. The civilization that waits may never welcome them back. Time itself enforces the price of longing. Still, we imagine. Science fiction paints visions of warp drives, wormholes, shortcuts through spacetime itself. These may remain fantasy, but they reveal the depth of our yearning. We dream because the stars compel us to dream. Even when law forbids, imagination does not. The constancy of light is unbroken, but the constancy of longing is just as relentless. Perhaps the longing matters more than the destination. The cosmos is vast, and we may never cross its greatest gulfs. But in longing, we are already connected. We are shaped by the stars we cannot reach, humbled by their distance, inspired by their light. To gaze upward is to participate in a dialogue older than civilization, a dialogue between human restlessness and cosmic silence. There is also a quieter truth in this longing. To desire the stars is to acknowledge that we are not enough for ourselves. We seek beyond because we feel incomplete within. This incompleteness is not flaw, but feature. It is what drives discovery, art, science, and story. It is what makes us human. The speed of light may restrain our bodies, but not our imagination. In imagination, we are already voyagers across galaxies. In dreams, we already touch the impossible. So the law holds, but the yearning endures. And in that endurance lies our deepest identity. We are creatures who know we cannot outrun light, yet we still run. We are beings who know we cannot reach the stars, yet we still reach. The longing itself becomes a form of travel, a journey inward, even as we remain bound outwardly. The human longing for speed, for stars, for horizons beyond horizons, may never be fulfilled in the way we hope. But it has already fulfilled something else. It has given us wonder. It has taught us humility. It has revealed that boundaries are not only obstacles, but mirrors, reflecting back who we are when we face what we cannot change. The speed of light is unyielding, but so is the human spirit. And in that tension between what cannot be surpassed and what cannot be silenced lies the story of our species. Closing reflection. The story of the speed of light is not merely about velocity. It is about boundaries, about the architecture of existence, about the conditions that allow reality to endure. From Einstein's revelations to the geometry of spacetime, from black holes to cosmic horizons, from human longing to the silence of the stars, the same truth has echoed. Nothing moves faster than light. And in that truth lies the coherence of the universe. Light is not only illumination, it is the measure of time itself, the rhythm by which clocks are kept, the heartbeat that synchronizes causality. It defines the slope of cones of possibility, carving reality into past, present, and future. Without its constancy, history would dissolve, cause and effect would blur, and meaning would collapse into paradox. The universe is not free despite this limit. It is free because of it. And yet, the limit is not cruel. It humbles, but it does not erase wonder. For the barrier of light has given us the stars. It has preserved their stories, carrying photons across billions of years to reach our eyes. It has bound the past into the present, allowing us to gaze backward in time, to see galaxies as they were long before Earth was born. Every glimmer in the night sky is a message written by light, a letter delivered across the immensity of spacetime at the only speed that preserves coherence. This boundary has also given us imagination. To dream of breaking it is to declare that we are restless, that we long for more than what is, that we see the stars not only as distant fires, but as invitations. The law of light may not yield, but our yearning rises endlessly against it, like waves against a cliff. In that resistance, we find ourselves. We are creatures defined not by what we can do, but by what we dream to do. In contemplating the speed of light, we also contemplate ourselves. We see the smallness of our lives against the vastness of the cosmos, the brevity of our years against the immensity of time. Yet we also see resilience, imagination, wonder. We discover that limits do not silence meaning, they give it shape. Without the boundary, there would be no story, no striving, no longing. With it, existence becomes a journey framed by law, but filled with possibility. And so, the closing reflection is this: nothing can move faster than light, but nothing needs to. For in the constancy of light lies all the coherence of the universe, all the beauty of the stars, all the wonder of the human spirit. It is not an obstacle to overcome, but a mirror to gaze into. A mirror reflecting both the vastness of reality and the persistence of our longing. The cosmos does not give us infinity, it gives us boundaries. But within those boundaries, it gives us everything. Galaxies, stars, worlds, and the light that binds them together. To live is to move within the cone of possibility, to dwell in a universe where light defines both what can be known and what must remain forever beyond. Perhaps the greatest gift of this law is that it reminds us of humility. We are not masters of the cosmos. We are participants in its order. We do not dictate the speed of light. We are shaped by it. And in that shaping, we find awe, meaning, and peace. So as this journey ends, imagine the night sky. Imagine the countless photons striking your eyes, each one born in some distant fire, each one having traveled across ages without duration, each one carrying the story of a universe that holds both limit and wonder. They arrive now, in this moment, at the only speed that existence allows. And in their constancy lies the most haunting truth. Nothing can go faster than light. And because of that, everything remains possible. We may never go faster than light, but we will never stop longing to try.